Hello, this is the solutions video for Physics Chapter 3, homework number 1. We're going to cover review questions 1 through 7 on page 102 and practice problems 1 through 5. Okay, I went ahead and put the answers to the review questions on the board here. So reading the question on page 102, we always define the angle of a vector relative to what? Well, it's the positive x-axis. So if you look at your coordinate plane, if you start here at 0 degrees and come back all the way around, the positive x-axis is where 0 degrees is. So that's what we define the angle relative to. Right, number 2, we've got four physics concepts, I guess. We want to know if they are represented by magnitude or angle. So speed would be represented by a magnitude. We don't think in terms of speed with an angle. Heading, though, is something you kind of think of with a map, and so that would be represented by an angle. Part C, a direction, also represented by an angle, and then a distance has nothing to do with angle, it's just a length, so that's represented by magnitude. All right, number 3 says, so we've got this drawing on number 3. We've got the coordinate plane, got a vector going straight up like that. And it says, consider the following vector. Does this vector have an x component? Why or why not? Well, it does have an x component, even though it's only in the y direction. It's just that the x component is 0. So not a big deal if you said no on that one, if the x component is 0. But you do give an x value and a y value to every vector, even if it's 0. All right, and then I have this coordinate plane drawn out with the 4 quadrants labeled, the positive and negative x and y axis labeled, and we'll refer to that on numbers 4, 5, and 6. So number 4 says, if a vector has an x component that's negative and a y component that's positive, which region of the Cartesian coordinate plane does it fall in? Okay. X component negative, that'd be to the left. Y component positive, that'd be up, so that'd be quadrant 2. And so if you were taking the inverse tangent of something in quadrant 2, we would have to add 180 to the number that the calculator gives us. Number 5 says a vector has an x component that's negative and a y component that's negative, so that'd be to the left and down, so quadrant 3. And in quadrant 3, you have to add 180. Number 6, x component is positive, so x is to the right, but y component is negative. That'd be down. That's going to be quadrant 4. And you have to remember to add 360 to your calculator number. And then number 7, estimate the angle of the following vector. To me, it looks like it's about halfway in quadrant 2. So straight up is 90, and this would be 180. So I would say that is split the difference between the two, and that'd be about 135 degrees. All right, so that's the review questions, and we'll get on to the more mathematical portion of the problems with our practice problems. Okay, so we are on page 104. We want to graphically add the following vectors. So I'm going to use this for both numbers 1 and 2. Let's draw this out. So A is red. So it looks to me like that's at about a 45-degree angle. It's pretty short. Okay, we'll call that A. And B looks like it's kind of splitting the difference in quadrant 4 there, but it's longer. And in number 1, we want to do, let's see, A plus B. We want to add them. So what you do is you take the second vector, which is B, you slide it to the arrowhead, so slide the back of B to the arrowhead. if we were to draw that, if we slide B over, right, and we put it like this, same angle, our resultant vector, we go from the origin, want to do a dashed line from the origin to, and we'll call that C. So it's going to end up in quadrant 4. This is a useful exercise to do, you'll see with the next set of homework, because it'll tell you where your answer should lie. All right, number 2, we're going to use this same one, and we want to do subtract vector B from vector A. So that'd be A minus B. All right, so it's the second one that you're going to change. So A is still something like that. Now B, we want to make negative. So the same length. So this is negative B. So that's A plus negative B is the same as A minus B. Now we're going to slide it over just like we were adding them. Okay. If I slide vector B over, something like that. So that's negative B. This is A. And we end up with a resultant that I would say is pretty much straight up, but probably would go over into the third quadrant just a bit. So that's our resultant vector C. All right, we've got another vector drawing. So here we have a plane. And we have it going at 0 degrees. Like that. And then we have the wind shown in blue here, coming kind of like that. So to add the two together, what's the resultant heading of the plane? We would just move this wind vector to the plane vector. So I would end up having that. Take the wind, put it on the arrowhead, and then of course it makes common sense that the plane would be pushed kind of down on this drawing. So we'll call that vector C. If you want to call the plane vector A and the wind vector B. So the resultant heading of the plane is going to be a little bit below the 0 degrees. So probably something on the order of 350 degrees, something like that. All right, and then the next two problems are trigonometry. Okay, number 4 says vector A has a magnitude of 35.1 meters per second. And direction of 215 degrees. What are its x and y components? So A sub x is going to be the magnitude 35.1. Cosine goes with x, so cosine 215 degrees. All right, and then A sub y, the only thing you have to change is cosine to sine. All right, so that's at negative 28.8 meters per second. That's not a magnitude, it's the x component of the magnitude. and negative 20.1 meters per second. Okay, we'll have to do this a lot on the next set of homework. Easy peasy. All right, number 5 says the velocity vector of a car is an x component of 17 meters per second, y component of negative 11 meters per second. What's the magnitude and direction of the velocity vector? All right, well, we're going to use Pythagorean theorem, so our magnitude is going to be the square root of the square of the two components. So square root of 17 squared plus negative 11 squared. All right, so that's 20.2 meters per second. That's our magnitude. And then theta, direction angle, is the inverse tangent of y over x. So that's going to be negative 11 over 17. Oh, forgot the inverse tangent part. Pretty important. So inverse tangent, negative 11 over 17. Now your calculator is going to tell you that's negative 32.9 degrees. But we're not going to report it that way. So what quadrant are we in? Well, y is negative, that's down, x is positive. So that's quadrant 4, isn't it? So we're going to add 360 to that. So the angle theta we're going to report is 327.1 degrees. So that's our answer, 20.2 meters per second at 327.1 degrees. All right, that does it for the solutions for homework number 1. I will talk to you next video.